Once we are dealt with the surface treatment, it's time to apply the adhesive. But which adhesives exist? That's what we will see in Module 4, Adhesive Families. We know now which surface treatments we should apply. It's time to look at the adhesive now and which adhesives we have at hand, especially for aeronautical applications. I start with the most important one, the epoxy. It's, as I said, by far the most used. It's very strong, but also very brittle. This astronaut, I think, is very clear and illustrates well the key point associated to this adhesive, strong. It has low shrinkage, about 5% when it cures. This is very good because if you have adhesives that have a high shrinkage, then this will introduce residual stresses in the adhesive. Epoxies have a low, limited shrinkage, which is nice. They can be supplied as one or two parts. When it's one part, then the resin and the hardener are pre-mixed, but then they should be kept at very low temperature to avoid cure initiation. Two parts, the resin and the hardener, are separated, and you just mix when you want to apply the adhesive. It has an exothermic cure, which is not very nice, because if you use too thick bond lines, then the temperature will increase a lot during the cure and might even burn the adhesive. The adhesive can be B-stage, that means it can be partially cured and supplied as a film, which is hard, but note that even a film adhesive that apparently is solid, when you apply it on a surface, it will melt because it needs to be heated, so it will go through the liquid phase that we know that is indispensable to have a good wetting. That's the main adhesive family of the epoxy. Those that cure at room temperature, in general, they use amines for the hardener. And in general, we are talking about hybrid epoxies. Pure epoxy is too brittle. So one typical way to improve the toughness of the adhesive is to mix it with rubber particles, and then we have toughened epoxies. You have in this table the most common film or epoxy adhesives used in the aeronautical industry. You see most of them are film adhesive. This one is a toothpaste, but most of them are film adhesive. In fact, the aeronautical adhesives, most of them are supplied as film adhesives. That's the most convenient way to bond big and smooth, plain areas. And this is quite a conservative industry. It's very difficult to change the adhesive. These adhesives are very, very well characterized, and that's the adhesive they will use. Very difficult to change to another adhesive, because then they will need to run another set of tests, which is very, very time consuming, very, very expensive, and they don't really know how they will behave. They are fully confident in these adhesives. Phenolics also, actually this is an historical adhesive. The first synthetic adhesive was a phenolic adhesive, a film. It's Redox 775, really historical in this industry. It's quite strong, and it's resistant to temperature, as the astronaut shows, and it's cheap. That's one of the most important things about this adhesive. But it needs a lot of pressure during manufacture. The adhesive, not so much. The phenolic, it needs a lot of pressure, otherwise you will have porous bond lines. And again, pure phenolic is too brittle. In general, they are modified with other adhesives. But why phenolics are particularly sensitive to the pressure? That's because they cure by condensation. Some adhesives cure by addition, others cure by condensation. And those that cure by condensation, during the chemical reaction, there will be a release of water. And because the cure is at high temperature, we are talking about vapor, and this will expand. So to counteract this effect, you need to apply a high pressure to make sure you don't have porosity in the bond line. All right? Then you have the polyaromatics. These are extreme adhesives for very, very high temperature. We are talking about 300, 400 degrees C for these adhesives. Polyimide, bismuthimide are examples of these types of adhesives. They have a lather structure that is very, very strong and withstand very high temperatures, but extremely difficult and very difficult to process. The manufacture is a nightmare. You have here a graph that summarizes the adhesives, the most important structural adhesives. You have strength versus service temperature. So phenolic, nice in terms of service temperature, better than the two component, as good as one component adhesive, but it depends, it varies, the one component epoxy. The thing about the phenolic is that it's very cheap. And then you have here, which apparently are the best ones, the aromatics, but I remind you that they are very, very expensive and very difficult to process. A word about non-structural adhesives. They are also important in aerospace applications, especially when you need high capacity of displacement, like silicone adhesives. So let me show you what I'm talking about. This is an epoxy adhesive, so very, very strong, like rock. And here you have a very flexible adhesive. This case is a polyurethane, but the silicone is something similar. Okay, you can feel it. And for some applications, you need this type of adhesive because this type of adhesive can compensate differences in coefficient of thermal expansion. So when you have big movements involved, then you use this type of adhesive. For example, they are used also to bond the ceramic tiles in the aerospace vehicles or cork tiles that I show you at the beginning in the introduction module. But because in general we are talking about very high temperature, we should be careful with the creep issues. Then you have a very, very special adhesive, this one. This is a ceramic adhesive. I told you at the beginning in the introduction module that adhesives are polymers. This is the only one that is not a polymer actually. It's a ceramic. And it can withstand temperatures that are compatible with the ceramic, more than 600. But this is for very, very particular application like encapsulating electronics, and it is extremely, extremely brittle, all right? So that's for the adhesives. You have the most important ones, the structural ones. That's the most interesting one. And don't forget, the king of the adhesive is the epoxy. And in the aeronautical industry, in general, we prefer film adhesives.